Right, so today I'm gonna make one more example about how to find the canonic form with Minterm and Maxterm. So let's suppose we have one new expression, which in this case is gonna be, I don't know, something f of x, y, and z equal to not x times y plus z. So how do we do this? Well, first of all, let's make our truth table. So, truth table. So in order to do that, we basically have to, we have to put all the different inputs inside the function and see what we get as an output. So first of all, let's count. So we have 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and 1, 1, 1. Now, in order to get the result, what we basically have to do is to plug all those three into our function. So if x is 0, so we got 0 naught times y, which is 0, plus z, which is 0. So 0 naught is 1 times 0 plus 0. Now we get 1 times 0 is 0 plus 0, therefore we get 0. So our result is indeed 0. And we're going to do this again. So we 0, 0, 1. So we get 0 naught, because x is 0, times y, which is 0, plus 1. So we get 0 naught, which is 1, times 0 plus 1. So 1 times 0 is 0, plus 1 is 1. So we get a 1 here. And again, so we get 0, 1, 0. So we get 0 naught times 1 plus 0. So 0 naught is 1 times 1 plus 0. So 1 times 1 is 1 plus 0 is just going to be 1. So we get 1 again. Then 0, 1, 1. We're going to do this one more time. So 0, 1, 1. We got 0 naught times y, which is 1, plus z, which is 1, so 1. 0 naught is 1 times 1 plus 1. So 1 times 1 is 1 plus 1 is indeed 1, once again. So get 1. Now 1, 0, 0, we had x, which is 0, so 0 naught. Whoops, I didn't make the arrow. There we go. So x naught is 1 naught times y, which is 0, plus z, which is 0. So 1 naught is 0 times 0 plus 0. This is meant to be 0. So this is going to be a 0. Indeed. Now, we got the last three. So this one, 101, we got 1 naught times 0 plus 1. So 1 naught is 0 times 0 plus 1. So 0 plus 1 is 1. And then we have this one. So 1 naught times y, which is 1, plus z, which is 0, so 0. So 1 naught is 0 times 1 plus 0. 0 times 1 is 0, plus 0 is going to be 0. And lastly, we have 1, 1, 1. So, whoops. So we get 1 naught times 1 plus 1. So 1 naught is 0 times 1 plus 1. So 0 times 1 is 0 plus 1 is going to be 1 anyway. So 1. Now, we can use either the Minterm representation or the Maxterm representation, just like before. I'm going to start with the Minterm representation. So Minterms. Now, in order to make use the Minterm representation, I'm basically going to rewrite the truth table real quick. 0, 0, 0, 0, 0, 0, 1 is 1, 0, 1, 0 is 1, 0, 1, 1 is 1, 1, 0, 0 is 0, 1, 0, 1 is 1, 1, 1, 0 is 0, and 1, 1, 1 is 1. Now, with the Minterms, we are actually interested in when the function output is 1. So we are basically going to ignore where it's 0, and we are just going to focus on where it's 1. So let's start from this. Again, since this is 1, we're basically going to check whether x, y, and z are 1. If they are, we're going to multiply them together by writing x times y times z. If they're not, and they're 0, then we're going to multiply their complement, so not x, not y, not z. In this case, x is not 1, so we write not x. Y is not 1, so we write times not y. And z is indeed 1, so we write times z. So not x times not y times z. And we're going to do the same for this one, which is second term. So x is not 1, so we get x naught times y, which is 1, so times y, times z. So z is not actually 1, so is 0, so we get not z. And we do that again for this. So not x times y times z. And one more time here, so x times not y times z. And lastly, the very last term, which is this one, all of them are 1, so x times y times z. Right, so those terms are the product, and since the Minterms are actually the sum of product, we're basically going to add them together, and the result is basically going to give me the canonic expression expressed as Minterm, which means expressed as the sum of product representation. So canonic form with Minterm SP, so sum of product, we get f of x, y, z equal to, well, the first expression plus the second expression plus the third plus the fourth plus the fifth. So not x times not y times z plus not x times y times not z plus not x times y times z plus x times not y times z plus x times y times z. So this is going to be our canonic form expressed with the Minterms, which basically means the sum of products. So those are sum of products. Now we can do this very same thing with the Maxterm. So let me just rewrite the truth table real quick once again. So result, I look at things messy in here. So 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 0, 1, 0, 1, 1, 1, 0, and 1, 1, 1. And then here we have 0, 1, 1, 1, and then we have 0, 1, 0, 1. Just copied it from above. Right, so now with the Maxterm, we are actually interested in the terms that have 0 as a result. So we're interested in this term, in this term, and in this term. We're just going to ignore all the other. Now, if we look at these, x, y, and z, in this case, we're actually interested in when each one of those are 0. So if they are 0, we're just going to write x, y, and z. If they are not, we're just going to write their complement added together. So x is indeed 0, y is indeed 0, and z is indeed 0. So x plus y plus z. Now here we have x, which is 1, so not x, plus y plus z. And lastly, we have 1, 1, 0, so not x plus not y plus z. Not x plus not y plus z. Now, those are actually the terms that form the product of sum representation with Maxterms. So our canonic form with Maxterms. So the canonic form PS, expressed as a product of sum, is f of x, y, z equal to x plus y plus z times not x plus plus y plus z times not x plus not y plus z. Not x plus not y plus z. So this is actually the product of sum representation, which is typical of the Maxterms. So as you can see, you can basically, whenever you get an expression, so a function like this one, you can actually express it. You can, find the truth table by basically inserting each and every value and just, find the output. And once you have done that, you can basically use either the Minterms or the Maxterm in order to find the canonic form. If you use the Minterms, you're going to have to look at where the function is 1, and you're basically going to have the sum of products representation. However, if you look at the Maxterm, you're going to have to look at where the function output is 0, and you're going to have the canonic form with the product of sum representation. And indeed, this is a product of sum. So I hope these two videos are, just what you needed, and kind of clarify how to find canonic form with either Minterms or Maxterms. If you need more example, I'll be happy to do that. But for now, I think this is going to be fine. Cheers and bye for now. And stay tuned for the new episode and next episode, of course.